Thank you. I feel like that's going to be a theme for the next 2 days. So the reason that I'm making a point about the University of Lincoln is just because that's where our research takes place, and it's also where we're based. So this is the map of the UK. It feels weird to be doing this sat down, I will say. So at the bottom, we have France, UK, and then Ireland off to the right-hand side. University of Lincoln is in the East Midlands of the UK, so pretty much in the centre of England. And our university has about 20,000 students, so medium to large by English standards. And our students are generally separated into 4 colleges. That's the College of Science, Social Science, Arts, and then our International Business School. This research is going to focus on that small subset of College of Science students, but I'm going to be making reference between science and social science as we go through this. So unfortunately, you can't see the title, but that just says mathematics anxiety. So just to formally define what we mean by mathematics anxiety, it's a negative emotional reaction to mathematics that involves feelings of tension, nervousness. Most importantly, those feelings then interfere with your manipulation of numbers and solving of mathematical problems. And it's that interference, it's the impact of these emotions that causes us the most problems with mathematics. Other forms of achievement emotions do exist. So commonly you have statistics anxiety, physics anxiety, and test anxiety. I'm going to be referencing that later on. We're focused on mathematics anxiety today. Estimated 85% of all students experience maths anxiety. And just to be clear, that's across all students, of which about 26% would describe themselves as having moderate or, severe or very severe anxiety. So it is a really large body of our students, 85% across all, and 1 in 4 say it's severe or very severe. We note that students with high levels of mathematics anxiety often experience and practice mathematics avoidance, and that can be at lots of different levels. At the task level, that can be students choosing easier methods or easier questions, or trying to avoid questions that they perceive to be very maths-based. I'll pick a word-based question, not a maths-based question. We see that very commonly. Also, we see it happens at the subject level. So thinking in terms of secondary education, that'll be students avoiding to study science where they can, avoiding choosing to study more mathematics. At the tertiary level, it's very much a university course. Okay. So that's looking at students that don't want to study math or science or any STEM course or medicine or nursing or technology. These students who are very capable, very interested, but just their fear and their nervousness of maths inhibits them accessing these courses and has massive impacts on later career choices. Here's a list of symptoms of mathematics anxiety, and it's separated into 2 cohorts here. We've got some emotional-based symptoms and physical symptoms. I'm going to make the broad assumption that most people here are academics at a university. I think we learned from Alessia earlier, it's about 75%. So please have a think about these symptoms in terms of what you might experience and what your students might experience. Do your students experience any of these symptoms? Perhaps not the emotional, but some of the physical ones you might observe. So the emotional includes feelings of helplessness, lacks of confidence, fear of getting things wrong and being frustrated in lessons. Overall, a general, I can't do this approach. Whereas the physical symptoms include your heart racing, some irregular breathing, sweatiness, shaking, biting your nails, feeling hollow in your stomach, having that sense of dread and that sense of feeling in mathematics. In my day job, I teach maths to pharmacy students, nursing students, education students, people that, generally speaking, don't want to be learning about maths and stats. And every time they walk into my lectures, oh no, it's the stats one again. Happens a little bit more than I'd like to admit, but it's these students having this nausea, having this paranoia, this fear, this dread. One example that I like to do with students, particularly those that are non-STEM, is a quick response to see if they have any physical symptoms. So if anyone's got a pen in their hands, just please put their pen down for this second. So I'm going to ask you a question. I want you to see how you immediately react to it. 17 times 9. I saw 2 people do it. When you talk about this maths imposition, hands go up. Particularly in students, the hands immediately come up and occasionally they start flapping. I call it the butterfly reaction. Hopefully I'm going to put that into an article one day, but it's hands come up and people start flapping. For some students, they tell me it's to stop seeing maths. They try and put a barrier between them. Others, it's just that jerk reaction. So where does mathematics anxiety fit in? This is one of the many cycles of maths anxiety. This looks at maths anxiety and maths performance. I would draw your attention immediately to the fact that these arrows are bidirectional. We're not at this moment suggesting any direct causality around this cycle. There is a lot of literature arguing that it's either unidirectional or bidirectional. For the purposes of what we're looking at today, we'll just accept it's bidirectional. If you want to talk about this with me at coffee, I'm definitely willing to talk about maths anxiety. So we'll go from the top and we'll work top to left, down to bottom, down to the right. So one of the biggest things we see is this link between maths anxiety and maths avoidance. People that are really nervous about maths avoid doing maths. Perhaps not a massive surprise there. And then Hembre is one of the many meta-analyses that prove that. Maths avoidance then links to poor preparation. If you're avoiding learning maths, you're not going to prepare very well for maths, which has the knock-on effect of having poor maths performance. And then we get to the last link, and perhaps the most impactful link here, and that's the relationship between maths anxiety and poor mathematical performance. And that's the killer. That is the one that causes us the most problems, because if students are worried or nervous about maths, they're not going to do well at maths. And if you're not doing well at something, you're going to feel worse about it. And if you then feel worse about it, you're going to do even worse. And we get down to this cyclical or this spiral pattern of maths anxiety and maths performance. Future work's looking at addressing that and specific interventions. Unfortunately, that's beyond the scope of what we're looking at today. So this is the factor analysis of the structure we're looking at. And these are some demographics of university students, specifically in the School of Mathematics and Physics at the University of Lincoln. I would just make it clear this data was collected 2 years ago. So previous works have looked at the structure of mathematics anxiety and the factor composition in widespread students, which includes education and pharmacy and psychology. Most of the time, these studies are looking at College of Social Science students. We're specifically looking at what we might assume is the most able and the students that have the least amount of maths anxiety, people that are choosing to study maths, that are paying a lot of money to study maths. To be clear, the maths and physics courses at the University of Lincoln have 83% overlap. So they are very similar courses. Just to mention on the sample, males 84, females 42, so in total 126. That's out of about 150, so a very, very high response rate. No one identified as non-binary, so we're keeping it binary for these purposes. Also to mention, we're only including undergraduates here. Postgraduates have a very different approach to their education in England, so we're just looking at undergraduates. The sample that specifies year 4 is 5. That is all of them. That's the reason I've included that small sample. So it is all year 4 students. And we're looking between maths, physics, and dual honours students. So dual honours are those that are equally enrolled in maths and physics. So we've got maths, physics, and then our dual honours students, which is a combination of the two. And here's where we get to. This is our factor analysis result, and you probably won't be able to read it in much detail, so I'm just going to talk through the primary things here. Firstly, we did CFA, confirmatory factor analysis, just to check, and kind of what our hypothesis was at the time, that the factor analysis structure of specialists, those that are maths and physics students, is the same as non-specialists. That was not the case. Our confirmatory factor analysis did not support a 3-factor model, and that's based on the chi-square independence and the RMSEA, root mean square errors. It didn't support a 3-factor model. So we took that as our motivation to run PCA anew and run our own exploratory factor analysis, where we learn about these 4 factors. Maths anxiety typically has those emotional and physical effects, and it has an emotive and cognitive element. And that's what we see in these factors. First, we have social, and that's any factors that are present in everyday life. So working out change in a supermarket is a really common example, being asked to separate a bill, and then being asked to calculate percentages and that kind of thing. Very social stuff that we'd all be expected to do. Second factor is the learning elements of maths anxiety, and that's where your maths anxiety appears in a learning-based environment. So in a lecture, in a class, reading a textbook, something like that. Thirdly is the evaluation-based maths anxiety. Just to be clear, this is separate from test anxiety, although they are incredibly well related. The evaluation maths anxiety is when you are being evaluated in mathematics in any context. So it's not just sitting an exam, it's anytime your ability is being evaluated. Some current work where we're looking at the maths anxiety of teachers, it's where the teachers consider themselves to be evaluated in their maths, even though they're not enrolled in any maths course. They're not doing any exam, it's not tests, it's just their ability being evaluated in mathematics. In our specialist sample, we've identified a fourth factor, and that's routine maths anxiety. That is the mathematics that is so mundane to these specialist students. Arguably, they wouldn't even consider this to be mathematics. So the four examples here are calculating how many days until a birthday. That's counting. What we're seeing is in lots of our maths and physics students, they're not considering that maths. Personally, I wouldn't either. I consider that counting. Also, one that was particularly interesting is being asked to memorize the multiplication table. Perhaps not surprising that that has been pulled out of learning if you're considering we have these third years and fourth year students. These students that are learning linear algebra, differential calculus, are they going to consider a multiplication table part of their learning? Or is it just something routine that happens every day? So based on this, we present a four-factor model with specialist students. In non-specialist students, that routine element is separated between social and learning. But in our specialists, routine comes out as its own factor. So once we've got these measurements, we did some testing, and I'm very honored to be the first one to present any p-values at this conference. I'm sure that's going to go down well later on. So what we've got is the UK MAS overall. That's the 23 item. For the subscales, we've used the 21 item. We had to remove 2 of those items because they were so unsuitable, it wasn't very straightforward or sensible to do so. What we're looking at here is a binary gender difference between males and females, and you'll notice with the p-values on the right, it's significant across the board. There is a significant gender difference in maths anxiety, with female students reporting much higher levels than male students, and that goes all the way through. Particularly, I draw your attention to the EMA, so that's the evaluation-based maths anxiety, of at least 3 points, and that's 3 points spread across 5 questions. So that is quite a sizable difference. These students, particularly these females in these cases, are really concerned about their maths anxiety. They have high levels of maths anxiety, and that does transpire into other effects. If we go on to have a look at the course-based description here, so this is looking at between maths, physics, and our dual honours students, you'll see that there are some significant findings, although not uniformly, and those significant findings where they occur are generally between the single honours students and the dual honours students. So postdocs indicate that's where the difference is. So what we're determining here is there is no measurable difference between mathematics and physics students. And of course, I'll acknowledge that limitation again. There is 83% overlap at Lincoln. So if there's no difference between our courses, can we generalize that finding not just from maths, but to wider STEM, or perhaps even to the entirety of, at Lincoln, we'd say, the College of Science? So if these findings are true, in students we'd expect to not experience maths anxiety. I think we've already had a comment this morning that we all have great capacity for science. We wouldn't expect people in this room to have maths anxiety or science anxiety, but it does happen. Even in students we expect to be the most able, if we jump forward, at the very top, those students that are spending multiple years of their lives studying maths or physics or STEM and spending tens of thousands of pounds for the privilege to do so, they still experience maths anxiety. They're still overcoming these barriers, these problems with maths anxiety they face because of their love for the subject. So what I'd recommend is that all STEM teachers, instructors, and lecturers should be acutely aware of the apprehension, the worry, the nervousness, the panic that their students face, and should be really cautious about how they interact with their students in their sessions. One of the examples is when I threw out that maths multiplication question, I didn't pick on anyone individually. Because if we start picking on students individually, there's lots of literature to suggest that's not the greatest pedagogy, but also it has the effect of singling students out, which again can directly increase their maths anxiety because you're directly assessing their evaluation, and it's the evaluation-based maths anxiety that we're impacting there. I'll conclude just with some facts that some future interventions should directly address the causes and effects of maths anxiety. That's the other work I'm doing as part of my doctorate, and should look at all students, including those we might otherwise expect to have low levels of maths anxiety. A lot of the literature in maths anxiety says, quite bluntly, we're not including College of Science students because they won't have maths anxiety. We've disproved that today. We'll conclude it there. List of references if anyone's interested in those, and of course, I'll be available for 2 days to answer any questions, including any questions now. Thanks, everyone.